Welcome back. The objective of this video is to explore some applications and give some context to inverse functions. So here in example 5, we'll let C of M be the cost in dollars of M ounces of mangoes. What do the following statements tell you? Be sure to use units. So C of 12 equals 0.75. Well, M is our ounces of mangoes, and this is $1, so this would tell us that 12 ounces of mangoes would cost 75 cents. And in example C, the inverse of the cost of 3 equals 48. So in this one, we flipped our inverse, our inputs and our outputs. So this really came from C of 48 equals 3. So order does matter here a little bit. So this says $3 will purchase, because we've flipped our inputs and outputs. So if I input $3, I'm going to be able to purchase 48 ounces of mangoes. I would not give full credit if you said 48 ounces of mangoes cost $3. While a true statement, really you have to write it in terms of inputs and outputs. So I have $3, now I can get 48 ounces of mangoes. Whereas in problem A, it's like, well, I bought 12 ounces of mangoes, so now I got to pay 75 cents. So a little bit like the converse back from your geometry days. Order does matter here. In example 6, we're going to explore W equals P of X. P of X is the average daily quantity of water in gallons required by a palm tree of a height X feet. So our output, or our Y here, is our water in gallons, and our input is the height of the palm tree. So that's our X, is the height, and then we output how much water is needed for a tree of that height. So what does the expression P of 25 represent? Well, 25, P of 25 equals some water in gallons. So a tree of 25 feet requires W amount of water, or this really represents the amount of water needed for a tree of 25 feet. What does the expression P inverse of 25 represent? Now this 25, this is the output, because we've got the inverse. So this 25 is the amount of water. So this represents our output here is, or this will represent the height of a tree that requires 25 gallons of water per day. Example C, what is the equation? And I'm going to change the V to X. P of X equals 50. Tell you about X, rewrite this in terms of the inverse of P. So P of X equals 50. Well, that's our output is 50. So this represents, we're going to find the height of a tree that requires 50 gallons of water. rewrite this equation in terms of the inverse of P, well, that's going to be the inverse P of 50 equals X. Palm trees, on average, are Z feet high, and a tree of average height requires K gallons of water. So Z feet high, that's our input, or our X. K gallons of water is our output, Y. So our function here, palm tree Z feet high, I might say like P of Z equals K. When I input the height, I output the gallons of water I need. So the inverse P of K is equal to Z. In example E, using the definitions of Z and K from part D, what do the following expressions represent? Now remember, Z was our height, our input, and our output was K in gallons of water. So P of 2Z, what are we doubling? We're doubling our input. So this would be the water for double the average height tree. And in 2 here, 2 times P of Z. Now our 2 is on the outside, it's impacting the Y. So this will be double the water for an average or a typical height tree. In example 3 here, P of Z plus 10, what are we adding 10 to? We're adding 10 to the height of the tree. So this would be a water needed for a palm tree that's 10 feet taller than average. And in number 4 here, P of Z plus 10, now we're adding 10 gallons not to the height of the tree, or 10 feet to the height of the tree. We're adding 10 to the Y's, which means 10 additional gallons of water. So this is 10 more gallons of water for an average height tree. In sample 5, we've got an inverse, the inverse of 2K. So this is really changing our Y. So we're doubling the amount of water. So this would mean double the water for an average height tree. And in example 6, the inverse of K plus 10. Now this is going to be 10 more gallons of water for an average or a Z height tree. And in sample 7, another inverse of K plus 10. This looks like our Y's are being increased, but our Y's, since it's inverse, our Y is an X. So this 10 actually refers to the height of the tree. So a 10-foot taller tree is going to take the average amount of water. Okay, so we could say the water needed for a tree 10 feet taller than the average. And in the last example, this is we're subtracting 2, and so now we're subtracting 2 from the Y. So this would be water needed for a palm tree that's 2 feet shorter than the average. In example 7, we'll take a look at some tables and their inverses. So we have to be careful about what's an input and what's an output here. In A, we have the inverse of -4 for our function f. So the -4 is actually an output in the f function. So our input that creates an output of -4 is 5. This is f of x equals -4. So that's an x of 5. And in b, it's the same kind of thing, but in the g function, the inverse of g of 6, so g of x equals 6. So we see the output is 6. Our input for that is 8. So the answer to that, x equals 8. In c, a little bit more complicated. The inverse of g of 1 of f. So if we input 1 in g, we get an output of -3. So the inverse of -3. So now it's just like our previous question, like in A or B. So I have an output of -3 in f, which is a result of an input of 3 in x. So that answer is 3. I'm working with this ordered pair right here. And in D, f of 0 is -1, and then the inverse of g of -1. So in g, my output is -1, so my input is 4. And so the answer to that one is 4. And that wraps up our video on providing context and application of inverse functions. And we'll get some more practice with this when I see you in class.